So what do we got going tonight? This is it, right? You got your final?
Yeah, I got it tomorrow.
Tomorrow, okay.
Well, the first part of it, it's the multiple choice. So
Okay.
not the hardest. But, so I have converting angles to radians.
Okay.
And the first one is 225 degrees.
Okay. What's the conversion factor?
I know that it's pi over 180, but I don't really know like how to multiply it.
Okay.
Really.
It's pi radians over 180 degrees. That's if you're going from degrees to radians. Because you want to lose the degrees and you want to end up with radians. Well, the degrees cancel and you end up with radians. Okay?
Oh, okay.
So the answer is 225 over 180 pi. Now, that's reducible. 15 goes into the top 15 times, goes into the bottom 12 times. 15 twelfths is reducible to 5/4. So it's 5/4 pi. Now, typically we don't use the units. In other words, I don't say 5/4 pi radians normally. I just say that the angle is 5/4 pi.
Okay.
And when you see a pi, it generally means radians. Now, if you're going from radians to degrees, let's say I have 3 pi over 4 radians, how do I convert that to degrees?
I'm not sure.
It's the same factor, but this time I want to lose the radians, right? And end up with degrees. So the degrees needs to be up there, radians needs to be down there. Well, it's 180 over pi. So it's either pi over 180 or 180 over pi, depending on which unit you need to lose and which you need to gain. You know what I mean by that?
Yeah.
Okay. In other words, when it's radians there, those cross out, and I'm left with degrees. And that is 135 degrees. In other words, the rest of it is just algebra. In other words, how I get 135 degrees, the pi's cancel, pi's cancel, and I'm left with 3 times 180 divided by 4. Well, 4 goes into 180 45 times. 3 times 45 is 135. And I still have the degrees right there. All right. And that's it. That's the only thing you need to remember is that conversion factor. And whether it needs to be 180 over pi or pi over 180 depends on which way you're going.
Okay. Yeah, that makes sense.
Okay.
Should we do something else, or should we do another?
Let's do one more. Make sure you can do it entirely on your own.
Okay. So the next one's 75 degrees.
Okay. What am I going to multiply by?
Multiply by 180, or pi over 180 degrees. And then the degrees cancel out.
Okay.
And then it's 75 divided by 180.
Now, simplifying those is not that easy. How would you simplify that?
Divide by 5.
Okay, that's a start.
So that's 15 over 36.
Can I simplify that?
Divide by 3.
Okay, what's that?
3 over 12.
Dividing
Oh wait,
3,
5 over
5
12.
over 12. And that's as simplified as you can do it. Because 5 is prime, and that's not a multiple of 5, so. Okay.
Okay, that
You
makes
don't
sense.
have to be able to reduce that down to this in one step, as long as you can do it in multiple steps. In other words, you need to
Okay.
be able to simplify it, but there's nothing that says you have to divide this by whatever, 15 to start with,
Okay.
top and bottom. So, all right, I would suggest we go, let's try one where you have to convert radians to degrees.
Okay.
Give me one.
I don't have 1 radians to degrees.
Oh, okay. Well, let's not bother with it.
I'm sure it'll be on there. But...
Well, let me make one up. Pi over 2 radians.
Okay, so that's going to be 180 degrees over pi. So then it's 180 pi, or no, it's 180 degrees divided by 2, which is 9.
There you go.
Yeah.
Okay.
Okay.
Let's try a new section.
Okay. This one says, without using a calculator, give the exact value of each expression.
Okay.
And then it says sine 60.
What are you allowed for this test? Are you allowed any note cards?
I don't think you're allowed anything.
Okay.
Is this unit circle?
Well, if it's less than 90 degrees, it kind of is not. If it's greater than 90 degrees, then yes, it's unit circle. But if it's first quadrant, in other words, these angles, anything less than 90 is first quadrant. If it's first quadrant, and you know what sine is, then the only thing you really need to memorize are these two triangles, along with their dimensions. These two special triangles that you've been studying for 2 or 3 years. What are their dimensions? One on what's opposite the 30?
60? Oh, I don't.
I call these my unit special triangles, and the reason I use that word is because I make opposite the smallest angle always 1. If that's 1, that's square root of 3, and that's 2. On the other triangle, if that's 1, that's also 1, and that's square root of 2. So you need to memorize those two. You memorize these two triangles, and you'll know all of your trig functions in the first quadrant. And that's a start for learning all the trig functions in any quadrant. First, you got to memorize the first quadrant ones. So what's the sine of 60 based on this triangle?
Square root of 3.
SOHCAHTOA.
So opposite over hypotenuse.
Okay, so what's the sine of 60?
Square root of 3 over 1.
Okay, there's the opposite. What's the hypotenuse?
Oh, over 2, sorry.
Okay. What else you got? What other angle?
It says cosine of 180.
All right. Now we're talking quadrangles. Quadrangles, you just kind of have to memorize the sine and cosine curves. Okay?
Okay. So with that, I have a unit circle that I can like memorize the curves on.
Yeah, the problem with memorizing the unit circle, this is what they want you to do. I just have never known anybody that could do it. Why? Because there's 16 marks on that unit circle. there's the four quadrangles, 90, 180, 270. And then there's each one is broken up into 30, 45, and 60. So by the time I draw the whole unit circle, I'm asking you to memorize 16 things for 16 different trig functions. That's a total of 96 things to memorize. Who can do that? I can't do it. So I don't really like that as a solution, that you can memorize the unit circle. I don't think anybody can. However, you can memorize a bunch of stuff grouped into 3 and 4 things. In other words, you can memorize that triangle. That answers all 6 trig functions for 30 or 60 degrees. This triangle, which is another 3 things to memorize, answers all 6 trig functions for 45 degrees. Okay? So anything inside the first quadrant can be answered with these 2 triangles. Now let's look at the unit circle. Well, let's ignore this quadrangle for a moment, because the unit circle is the next most important thing to memorize. That's quadrant 1, that's quadrant 2, that's quadrant 3, that's quadrant 4. If we have all of these memorized, which you will if you memorize these 2 triangles, then when we get into the second quadrant, the only thing we really need to memorize is the fact that we're going to take whatever angle we're given and apply that to it to figure out what its equivalent first quadrant angle is. In the third quadrant, it's that angle minus 180, and in the fourth quadrant, it's 360 minus theta. Okay? So let's take a question like, what's the cosine of 150? I'm going to put off the quadrangles until we finish this discussion. This is far more important. How would I get the cosine of 150?
So do I do 180 minus 150?
First of all, you have to figure out which quadrant it's in.
So then it'd be quadrant 2.
Correct. Now you use this formula.
So then it'd be cosine 30?
Yeah, so it's the same number as the cosine of 30. Not necessarily the same sign, but the same number. Now, one last thing you need in your unit circle is all students take calculus. That's going to tell you what the plus or minus sign is. So first of all, let's come up with a number. What's the cosine of 30?
Do I do that on my calculator?
No, you can look at one of those triangles.
Oh.
That's why these 2 triangles will tell you every standard trig angle without a calculator.
So then it's adjacent over hypotenuse.
So what is it?
So then it's the square root of 3 over 2.
Okay, and what's its plus or minus sign in the second quadrant?
Negative?
Correct. In other words, the only one that's positive is sine. And, of course, the reciprocal to sine, which is cosecant, but not cosine. So a negative goes there. And that's the answer to the cosine of 150 degrees, is negative square root of 3 over 2. Okay? So this unit circle that we're looking at here will give you everything except your quadrangles. Let me test you. What's the tangent of 225?
So that's in the third quadrant. So then it's 225 minus 180.
Okay.
Which is 45.
Okay.
And then
get your triangle up there to figure out what the tan of 45 is.
Okay. So that's opposite over adjacent, and then that's 1 over 1.
Okay. And then what's the plus or minus sign on tangent in the third quadrant?
Positive.
There you go. That's how you do them. That's all there is to it. Okay? Except the quadrangles. Quadrangles we have to treat differently because these triangles don't give you those 90, 180, and 270. Those are the quadrangles. So to get the quadrangles, you have to do one of two things. You have to either memorize the sine curve and the cosine curve, or there's another technique that's not bad, but the thing is you need to memorize these curves anyway.
Okay.
On the horizontal axis, what's that point right there? What's that point? What's that point? What's that point? What's that point? In other words, it's not just memorizing the curve. This is sine x. This is cosine x. But it's memorizing these quarter points. The first thing in memorizing the quarter points is to know where the end of the period comes. It's 2 pi, or 360 degrees. In other words, once around the unit circle gives you 1 period of your sine function.
Okay.
If that's 2 pi, what's this point right there?
Well, 1/2 pi, or 1 pi.
1 pi. What's this point right there?
That would be 1/2 pi.
And finally, what's that point right there?
1 and 1/2.
Right, 3 pi over 2. Okay, so let's go through the sine. What's the sine of 0, which is a quadrangle? Well, this point here is 1, this point here is -1. Same on the cosine. So what's the sine of 0?
1, 0.
0. In other words, it's whatever the y-axis says. Okay? What's the sine of 90 degrees? Which is pi over 2.
That would be 1.
Huh? What's the sine of pi, or 180 degrees?
Wait.
You're reading this curve right here.
I thought, oh, that's 0.
Got it? What's the sine of 3 pi over 2?
-1.
And finally, the sine of 360 degrees.
0.
Okay. So that's probably the best way to memorize your quadrangles, is to just know this curve. And you need to be able to create this curve from memory in order to know your quadrangles. Not just to know your quadrangles, but in all trig that you're going to take afterwards, you're going to need to know these curves by heart. Okay?
Okay.
The cosine curve has the same 4 quarter points. It begins and ends in 2 pi, which makes that pi over 2. In other words, all of the important stuff happens at these quarter points. By that I mean it goes back and hits the x-axis at the first quarter point, goes down to its lowest value at the second quarter point, comes back through the x-axis at the third quarter point, goes up to its peak value at the end. So your original question was, what's the cosine of 180 degrees?
1.
Look at the curve. Where's 180?
Oh, wait, okay, sorry. That would be -1.
You got it. That's the best way I know of handling quadrangles. You kind of kill 2 birds in 1 stone. You may not need to have this curve memorized for your test tomorrow, but at some point when you take trig, you're going to have to memorize both of these curves. So in order to handle the quadrangles tomorrow, the best way to really do it is to just memorize these curves.
Okay.
Notice sine starts at 0, cosine starts at 1. So the cosine of 0 degrees is actually 1.
Okay.
Okay, that's worth knowing, those two things. Okay, so again, there's how many things to memorize here? Not really. There's 3 or 4 things to be able to recreate this curve. One is it starts at 0 and goes up. Once you get that part down, the rest of it kind of takes care of itself. And know that its entire one period is 2 pi for both sine and cosine. Yeah. Once you know that, then it's easy to break them up into the quarter points and know that the first quarter point's got to be at its maximum, the third quarter point it's at its minimum, and so forth and so on.
Okay, yeah, that makes a lot of sense.
Okay. What other specific questions do you have? I mean, specific trig functions that they're asking about.
Oh, so the next one is tan 225.
Ah, that's the one I gave you.
So then that one is quadrant 3.
Uh-huh.
And then opposite over adjacent.
Mm-hmm. So what's its equivalent first quadrant angle?
Oh, 45.
Okay, and now look at this triangle and figure out what tangent of 45 is.
1 over 1.
Okay, what's the sign? The plus or minus sign on it?
Positive.
That's the way all of them go. Bang, bang, bang. Convert it to a first quadrant angle. Figure out what the first quadrant function answer, the ratio is, and then use all students take calculus to put a plus or minus sign on it. That handles every one of them except quadrangles. Quadrangles can be handled by this. There's also a tangent curve if you have tangent of quadrangles. We'll see if you get that before we go there. I don't want to give you too much to memorize. I mean, I don't want you to have to memorize anything that you don't need for tomorrow.
Yeah.
I'm correct in that this is trig as part of a Algebra 2 class, right?
Yeah.
Okay. They may not ask you tangent of quadrangles.
Okay. Okay, so then the next one is going to be sine of pi over 4.
Okay. Which quadrant is that in? There's 2 ways you can do this. You can kind of memorize stuff in radians also, or you can just convert everything to degrees to start.
Okay.
I would say convert everything to, if you're going to memorize the table that I've laid out here, then you're going to want to memorize, you're going to want to convert stuff to degrees. Because these apply to degrees, not radian measurement. Okay. So convert that to degrees first.
So then that's pi over 4 times 180 over pi.
Okay.
And then the pi's cancel out, and 180 divided by 4 is 45.
Okay. Let me point something out here. Pi over 4 equals 45 degrees. Pi over 3 equals 60 degrees. And pi over 6 equals 30 degrees. Notice the commonality. This times that is 180. This times that is 180. This times that is 180.
Okay.
As long as you have just pi in the numerator, it's pretty easy to convert these, and eventually you'll memorize these. So you won't have to do that conversion factor. In other words, you'll know that pi over 4 is 45 degrees.
Okay.
Okay, so now we're going to, in other words, the problem is now the sine of 45 degrees. What is it?
So then it's first quadrant. I forgot what to do if it's first quadrant.
They're all positive in first quadrant. But we get it from these two triangles. Find the 45 degree angle and figure out what the sine of that angle is going to be.
It's going to be 1 over the square root of 2.
That's correct, but you're not ever going to see that answer as a multiple choice. Why? It's got an irrational denominator.
Oh, okay.
So how do I change that?
Don't you multiply it by, like, it's the opposite or something?
Well, in order to get rid of the irrational denominator, I need to multiply it by square root of 2. I'm only allowed to multiply this fraction by the number 1, so I got to multiply the top by square root of 2 also. And that ends up being square root of 2 over 2. This answer you will see on the multiple choice tests. Because notice it no longer has an irrational bottom. These two are the same numbers. You put either one of them into a calculator, you'll get the same decimal. The only difference is this has an irrational denominator, which is not allowed. This does not.
Okay, so it's like a fraction.
We've rationalized the denominator. That's what it's called, is rationalizing the denominator. If that was 3, then I'd have to multiply it by square root of 3 over square root of 3, which then becomes square root of 3 over 3.
Okay, that makes sense.
Okay. What else?
Can we do one more of these ones?
Sure.
Okay, so I have cosine of 2 pi over 3.
Okay. Convert that to degrees, first of all.
So then that's times 180 over pi.
Okay.
And then the pi's cancel out, so that's 360 over 3.
Which is?
That's 120.
Okay, so it's the same question as the cosine of 120 degrees. Now, which quadrant? Step 1 is always identify the quadrant.
That's going to be second quadrant.
So what's the equivalent first quadrant angle?
That's going to be 60.
Okay. So now what is the cosine of 60?
It's opposite over hypotenuse, or adjacent over hypotenuse. So square root of 3 over 2, and it's...
Hold on. We're dealing with that 60 right there.
Oh, so then 1 over 2.
Okay. So that's the right number. Now we just need the right plus or minus sign on it.
And it's negative.
That's the 3-step process. No matter what the angle is, identify the quadrant. Step 1. Figure out its equivalent first quadrant angle. Step 2. And step 3, put a plus or minus sign on there, appropriate to all students take calculus. Between those 3 steps, you can do any angle for any trig function that is a multiple of 30, 45, and 60, and that's all the ones they're going to give you if they say do it without your calculator. In other words, I don't know how to do sine of 21 any way but doing it in a calculator. But sine of 30 I can do, sine of 45 I can do, sine of 60, all of those are doable. Those are the ones they want you to be able to do without a calculator.
Okay.
What else?
I have. One sec. It's on my computer.
You have any negative angles?
I don't on this paper.
Okay. Let's not go there. That's a whole nother topic. It's not complicated, but I don't want to give you all the trig I know. I only want to give you the trig that you're going to need for your exam tomorrow.
Okay, so, okay, here it is. The last one is tan of 3 pi over 2.
Okay. That's a quadrangle.
Okay, so
I'm
then,
trying to figure out the best way to teach you how to do quadrangles for tangent. Because the way I told you to do them for sine and cosine was to memorize those two curves. Well, there's a third curve, and that's the tangent curve. The tangent curve is quite different than the sine or the cosine curve. It has vertical asymptotes. And they happen, the first one is minus pi over 2, the second one is pi over 2, and the tangent runs its entire course in just pi, not 2 pi. The period of sine and cosine is 2 pi. Tangent repeats every pi.
okay,
And this is pi after that, that's 3 pi over 2. So looking at my tangent curve, what is the tangent of 3 pi over 2, which is the same as the tangent of pi over 2? What does it look like it's doing?
well, is it 0?
Going to infinity.
Okay,
It's 0 right here, but that's pi.
okay,
So the tangent of pi would be 0, but the tangent of pi over 2 is infinity, and the tangent of 3 pi over 2 is infinity. In other words, it never hits this vertical asymptote. It just, as we get closer and closer to 3 pi over 2, tangent is going to infinity. So what they say is that it's undefined. They don't say it's infinity, but they say it's undefined.
okay, so then that would be what I would answer on a test?
Undefined.
Yeah. Okay.
Yeah, that would be one of your multiple choices. Yeah, I don't really like using the word undefined in place of infinity, but they do. So, because they don't really mean the same thing. In other words, it's negative infinity if I get close to pi over 2 in this direction. Well, one's positive infinity, the other's negative infinity. They're going to say both of them are undefined, but that's fine.
Yeah, okay.
That's fine. Now, whether you have to memorize this whole curve or not for tangent, I don't know. This is pi over 2, that's pi over 4, which is 45 degrees, and the tangent we know is equal to 1 at pi over 4. So that points on the curve also. But as far as your quadrangles go, there is another way to memorize those that doesn't involve you having to memorize these curves. That's probably the way they taught you. And it has to do with the unit circle. Boy, I don't know. We don't really have time. I totally spaced out the time. I apologize. So maybe you just want to memorize those tangent quadrangles. Flat out memorize. By that I mean tangent of 0 is 0. Tangent of 90 degrees, which is pi over 2, is undefined. Tangent of 180 degrees is 0. Tangent of 270 is undefined. And the undefined means it's infinity, basically.
Okay.
Okay?
Yeah.
Just memorize those four things, and that'll take care of all your quadrangles for tangent. You could do the same with sine and cosine. The only thing with sine and cosine is you really do need, maybe you don't for your test, but at some point you need to be able to recreate these curves from memory.
Okay.
Okay? All right, Colin, good luck on your exam tomorrow.
All right. Yeah. Thank you so much for your
Yeah,
help.
you're welcome. And you're going to be taking Trig Pre-Calc next year?
Yeah, I'm gonna be taking pre-calc.
Good. Let me know if I can help.
All right. I will definitely.
Okay.
Thank you.
Have a good summer, Colin.
All right. Thanks.
Bye-bye.
You too. Bye.